Y'all have seen a lot about quadratic functions. Okay. So I'm going to tell you what the vertex form of a quadratic function is. It's a times x minus h squared plus k. Now, is that somewhat familiar? If you're trying to see this on the video, it's kind of blurry, so let's make sure. Okay, there we go. We'll leave a picture there for a couple of minutes to get a little more on the board. Okay, so what I want to do though is just see what you think, or you think you've seen some of this. Okay, so in my section, four by four square becomes 4a by 4. And the red dot moves to point HK. So you've seen all that. Okay, if you're in my class. If you're not, I'm gonna just draw a little picture of it. It's like you've got a 4 by 4 square here. And we've got our basic y equals x squared parabola in here. It's the x-axis here and the y-axis here. We transform it by making the square taller or shorter. Okay, so just schematically, okay, maybe we make it somewhat taller. And we can try to keep the center where it should be. And we have the same shape, but it's elongated along with the square. That's really kind of fun. Okay. And then we can move that any place we want. So if we want to move the red dot here, there we have our graph. And it should have the same size and shape here as it does here, but I blew it. You get the idea. Okay. So this function is y equals ax squared. And if this is a point HA, this is the function y equals a times x minus h squared plus k. Now, of course, if a is a negative number, that reflects this thing through the x-axis before we log in. Now, that should be something you understand just from what you know about transformations, having done the assignment on transformations. So that if you have this equation, it should be pretty easy to sketch a reasonable graph of the function. You don't necessarily need to use these squares. You get the idea that you start with the basic squaring function. And maybe it's not in the square. I like the square. well, I can't get it symmetric without a good square. So that's a bad picture, but and we transform that by just to do a different transformation. Let's go ahead and turn it upside down and make it skinny. Okay. And we don't necessarily have a red dot at the vertex, but I'm going to do it anyway because that just means vertex is a really important, unique point on this graph. And then we can take that graph and move the red dot wherever we want to. So maybe we move the red dot here. And now the function looks just like this. I'll try to make those about the same shape, but it's centered up here. So again, here is y equals a times x squared. Here it's y equals a times x minus h squared plus k. Now, one thing I did in my class, we did these transformations and we did estimates of the coordinates of points on this thing, and we then plugged the coordinates back into this function to see if what we got makes sense. And that gives you a better sense of what the thing, what the function is. But that's all I'm going to say about the way we did it in my class. Okay. But that's to make it even more real to those who did. Now, of course, we sacrificed some time to do that, and it wasn't necessarily a good decision. That remains to be seen to approach it the way we did in our class. For anybody, we should understand this, having done the assignments and transformations. And also the idea that the transform function has this form. F of x is the squaring function. Then f of x minus h is x minus h squared. So this thing is a x minus h squared plus k. If this was the exponential function, we wouldn't have the x minus h squared. It would be up there in the exponent. If it was a reciprocal function, it'd be a reciprocal of x minus h, 1 over x minus h, or a over x minus h. Focusing on the quadratic function, this is the vertex form. And I'll call it q of x, the quadratic. Q of x equals a times the quantity x minus h squared plus k. Okay. Now, we have other forms. The open math, I believe, calls this form the intercept. Y equals x minus a times x minus b. Now, this is something that I talked about in my class, but we will, of course, when we get to this another week or so. What value, can you give me a value of x, a symbol for a value of x that would make this 0? Okay. So we got good answers here. The first answer was, well, x equals a. Yeah, a minus a is 0, and 0 times x minus b is going to be 0 no matter what x minus b is. Okay. And then somebody said, well, a or b. Yeah, same thing for b. So y equals 0, if x equals a, or x equals b. So what do we have? Well, let's say a is here. So this would be the point A0, and maybe this is the point B0. Make sense? Okay, because if x equals a, y is 0. So if x is a, y is 0. If x is b, y is 0. That's why we have A0 and B0. And of course, anything with a 0 y coordinate is on the x-axis. So these are the intercepts. That's why we call this the intercept point. So this is intercept form. I've always called it factor form. I never really used the term intercept form, but I like it. So I'm going to use it. And Open Math uses it, so I probably better use it. Okay, so intercept form, x minus a times x minus b. Now, what's the y-intercept? How do you find the y-intercept for any function? Okay, now we're looking for the y-intercept, but we're having a little trouble because we don't remember what the condition for y-intercept is. And that's because, we're still sorting out things about the coordinate plane and stuff. So let me just pick a point here. Okay, here's a point. Is the x-coordinate positive or negative? Just positive or negative. Okay, what about here? Now, I don't know, maybe the x-coordinate is going to be on the line, vertical line through this point, it's going to be here, and that's positive, isn't it? Which coordinate is negative? The y-coordinate's negative here, right? Okay. Now what about a point over here? Is the x-coordinate positive, negative, negative? Okay. What about here? 2 out of 3 are missing this. The x-coordinate, you got to visualize a vertical line through the point. And remember, I've been trying to get people to draw vertical lines and horizontal lines through their points. We didn't see a lot of that in the test. So even though the results on the test were encouraging, I'm pretty well pleased with the results, we got to work a little bit more on getting these vertical and horizontal lines and understanding what they tell us. Okay. So we'll be working on that in here and in that class. So at this point, if you draw a vertical line, just visualize a vertical line. Where's it hit the x-axis? It's negative, right? Okay, now what about here? What can you tell me about the x-coordinate here? It's 0. Well, that's a condition for y-intercept. We used that when we did the intercept form of a straight line. Okay, x-intercept occurs when y equals 0. Y-intercept occurs when x equals 0. We don't want to just remember the words. We want to understand why, which is why I just tortured you with these questions. Okay. Okay, so the y-intercept, it occurs when x equals 0. Okay, well, when y equals 1, if x equals 0, what do you get for y? Okay, now, not everybody's seeing what to do with this. We say x equals 0. That means you can take the defining equation here and replace x with 0. So what do you get if you replace x with 0? Okay, well, first place, not everybody was real quick at writing this out with 0 instead of x. But, it's y equals x minus a times x minus b. If x is 0, then what you have is 0 minus a times 0 minus b. So it's a simple substitution. Now, a lot of times when we're doing something step by step, you're worried about what happens 2 or 3 steps in the future. Just one step at a time. Take a look at, if we have x equals 0, now we're going to plug X into the equation. Okay, plug 0 into the equation. And there's what we get. Now, what's 0 minus A? Now, and of course, this is a little bit unfamiliar because we don't have numbers, we've got letters. Okay, we have minus A times minus B. 0 minus A is negative A. 0 minus B is minus B. Now, what do you get if you multiply negative A by negative B? So this equals AB. Now, look, don't look at what anybody else says because they're probably wrong too. Okay. Seriously, look. Is AB positive? Is it negative? Or can't you tell? Positive, negative, don't know. Everybody thinks it's positive, but you're wrong. Okay. I said, don't look what everybody else says, they're probably wrong too. That's the answer I usually get. It depends on what A and B are. A is a number and B is a number. Can you give me two numbers that when you multiply them, give you a negative? How many people could easily give me two numbers that multiplied together give you a negative? And I think maybe you could do that. Okay, well, let's see if you can. All right, can you write down two numbers on your paper such that when you multiply them, you get a negative? Okay, so you got two numbers, you want to multiply them and get a negative, right? Well, people wrote down numbers like A, B. There are only three possible choices for any number. It's a real number, it's either positive, negative, or 0. Okay, so we asked, could AB be negative? Okay, because everybody thought that AB would be positive, and it looks like it ought to be because there's no negative sign there, but A and B are both numbers, so I asked you to write down two numbers that would give you 0. I saw negative 1 times 2 equals negative 2. I saw negative 1 times 5 equals negative 5. And what else did I see? It's the last one I looked at. How could I forget that? I think it was 2 times negative 5 maybe equals negative 10. I'm not sure about the negative sign. The second one is negative. Okay. So we have A negative, B positive, A negative, B positive, or A positive, B negative. Now, how could we summarize the condition for being negative? A, B is negative, A and B have different signs. Okay. Now, what about AB is positive? Without writing all the words, I'll just say same sign. So they could both be negative and you'd get a positive. Okay. So long as the signs are the same, you're going to get a positive. What about how could AB be 0? I could say A is 0 or B is 0 or both. Okay. Well, that means we don't know from this whether the y-intercept is positive or negative or zero. Okay, and let's look at three possible cases. Okay. Again, we have y equals x minus a times x minus b. So somewhere here we have a and we have b. In this case, a was negative and b was positive, right? So what's this tell us about the y-intercept? We have x here and y here. A is negative and b is positive, so the y-intercept is negative, right? So for this picture, a is greater than zero, a is less than zero, b is greater than zero, so ab is less than zero, and ab is the y-intercept. So when I picture this, I've got to have zero AB here. I can't put zero AB up here, or I can put it up here, but it's not going to correspond to this function. Okay. So zero AB, well, I can't put zero AB up here because A and B have different sides. They're on different sides of the y-axis. Okay, so we have the point zero AB down here. So that was a bad place to label it. So can you sketch the picture I just did and then sketch a quadratic function corresponds to the picture? Okay, so I'm going to put AB down here, but I want to label it here zero AB. There's your y-intercept. It's still not very good. Okay. I kind of punched things up here and didn't anticipate where I was going to draw this. Okay. So can you draw a picture that looks a lot like this one and then draw the graph of a parabola that passes through these 3 points? Okay, now there's a tendency, and I thought there would be, there's a tendency to want to draw it like this. What's wrong with that? Is that a parabola? What's wrong with it? Okay, so this is not an easy question. As I said, I was thrown to the wolves in an engineering calculus course at a tough school without having had pre-calculus. I knew a lot of other stuff real well, or wouldn't have been allowed to get into that school. But I never had the opportunity to even ask that question. I doubt if anybody was going to ask it anyway, but I think it's a good question. Okay, so I'm just saying, if you can't do this, I don't know if I could have done it. Even though I have extremely good math, except for calculus. Okay, so here we have it. And the way we do this is, well, this thing has to be symmetric. And what people said, the problem with this is it's lopsided. It's not symmetric. Okay, so this is not a parabola. If I'm not right, that's I didn't have room. And when I started, I didn't know how much I was going to say, but there it is. This is not a parabola, so it's not quadratic. It doesn't represent a quadratic function. And this is a quadratic function. We'll see why in a minute. We'll just multiply it out. We're going to get an x squared and some stuff. But we're going to do that slowly. Distributive might be a little bit rusty. Okay, it's got to be symmetric. Well, if it's symmetric and this point's on it and this point's on it, then where's the axis of symmetry? Where would the axis of symmetry be? Just for these 2 points. We're not even worried about this. We'll deal with it when we figure out where the axis of symmetry is. Well, anybody want to take a stab? Anybody have a? Well, I was hoping we get a good answer. We did. Okay. I think everybody was on track. Somebody got it first. That's no big deal. Okay. It's going to be halfway between these points. It's the only way we're going to be symmetric. That's the only way these 2 points are going to be symmetric to the axis. So we find the middle, which would be maybe right about here now. Symmetry halfway between the x-intercepts. So we know that the vertex has to be on the axis of symmetry. Okay. Well, that means we're going to come down here and we're going to have a vertex down here someplace. We kind of trace it out. Where should it be? Should it be about like this? Yeah, I think so. So let's just try it. Okay, it's a little lopsided this way because I can't draw, but you get the idea. Okay. That makes sense. That's an important picture. It's important to understand the axis of symmetry is halfway between A and B. What's halfway between 2 numbers? How do you get a number halfway between, let's say, 4 and 12? Okay, so what's the x coordinate of this point? This is x equals, okay, here's A0, here's B0. This line, this axis of symmetry, x equals 1. If you add 2 numbers and divide by 2, you get the numbers halfway between. You can test it out. Said, okay, what's halfway between 4 and 12? And people said 8. Yeah, people got that by counting backwards from 12 and up from 8. That's perfectly good. Shows you I understand something about numbers. Okay. But also, if you add 8 and 12, you get, add 4 and 12, you get 16, and half of that is 8. All right. So there it is. X equals A plus B over 2. That's going to be useful. Okay. Well, show me another picture. Right, here's a different picture. Okay, here's A and B. Where is AB? Now, we don't have a scale on the y-axis, so you can put it anywhere on the y-axis except, well, you got half the y-axis to choose from. Okay, so what you see about this is A and B are both to the right of the y-axis, which means A and B are both greater than 0. If A and B are both greater than 0, that means that AB is greater than 0. So A greater than 0, B greater than 0 implies AB greater than 0. So it has to go on this side of the x-axis. It has to go on the positive y-axis. So here's your point, 0 AB. Now, can you draw a parabola? Okay, so I think you're doing well. I've seen at least one paper where we've got an axis of symmetry here, which is very helpful. And then we just try to form the shape of the parabola. That came out better than most. Still a little lopsided. Okay, get the idea? All right. Okay, so we want to multiply. This is in the form x minus a times x minus b. How do we multiply x minus 5 times x plus 9? See if you can do that. Maybe just a minute or so. Okay, now what I see most people have done is you got to multiply x by x, and you got to multiply x by 9, and you got to multiply minus 5 by x, minus 5 by 9. And that's the way most people are thinking about it, okay? And that's correct, but why is that correct? Okay, it's a habit, but let's make sure we understand the rule. It's an application of the distributive law, okay? So I'm going to do this in 2 steps. I'm going to say, well, this is x multiplied by x plus 9. So the x multiplies the x plus 9, right? And then it's minus 5 times x plus 9. And then we can multiply x by x to get x squared, and x by 9 to get 9x, because x multiplied by x plus 9 is x times x plus x times 9. Okay, and there's minus 5x minus 45, because it's minus 5 times x and minus 5 times 9. And then, of course, and I think you all are fine with this, we get this. Okay, so now let's say we wanted to solve x minus 5 times x plus 9 equals 12. What would you do in order to solve that? Now, if it's x minus 5 times x plus 9 equals 0, you could solve it. X would be either 5 or negative 9, and that would give you 0. But if you got a 12 there, you're kind of lost. If you don't, expand, you get x squared plus 4x minus 45 equals 12. Okay. Now, once you have it in that form, what can you do? And you've done it already in pre-calculus. Okay, well, in my class, we did this in the first week or so. We were moving the squaring function around. And you probably remember that. In any case, we subtract 12 from both sides, and I'm going to do that. Writing it out the way I really want people to write it out. I don't like writing the 12 and the 12, or the negative 12 and the 12 down below here, because I'm just seeing people doing too many bizarre things. Not so much you all, but I've seen unbelievably bizarre things when people do that. You subtract 12 from both sides, that's what you're doing. It's not just you write a negative 12 here and a negative 12 there. Do something with it, which is often wrong. Now, again, I'm not saying you all make that mistake. I just want to emphasize, I really don't like that style. So we get this, and now we apply quadratic formula, which you might or might not remember from having used it 2 weeks ago. Okay, and that's where we're just going to stop there, because you know how to do that. You might not remember the formula, you might, depending on how often you've used it in the last month or so. Okay, but you'll remember it after doing the homework. And of course, it's something you need to remember. Okay. Okay, well, that's good. Okay, let me show you now a secret. And I have more time, I'd prove it to you, but I think that might be overkill. If y equals ax squared plus bx plus c, then the symmetry is the line x equals negative b over 2a. Now, that's not really a separate formula that you have to remember, because it comes right out of the quadratic form. Now, let's just note that the quadratic formula gives you the x-intercepts, because the quadratic formula is what you get when you set this. Well, quadratic formula says what x is in order to make this 0, and that's where the y-intercepts are. Right? So that's something I think you'll get used to. Now, this, do you see a negative b over 2a anywhere in this formula? Yeah, if I ask you to come up and circle it, you can probably do this. Okay. And it makes sense that this should be, because you have a plus or minus over here. Okay. So that's going to give you a 0 on the plus side of whatever negative b over 2a is, and 1 on the minus side. And the negative b over 2a is going to be right in the middle. And we just saw that the axis of symmetry is right in the middle of the zeros, the x-intercepts. Okay. So there's an explanation. I'll make that a little more clear. I mean, I said it as probably as clearly as I usually say it, but I'll try to draw that out a little more actually in our pre-calculus class and other pre-calculus classes. It might be sufficient just to memorize the formula, I don't know. But that's an important connection. And what I just said explains why this has to be the axis of the vertex, because this is halfway between the two answers you get here, because negative b is halfway between negative b plus and negative b minus the square root. You got negative b plus the square roots here, negative b minus the square roots here, and negative b is right in the middle. Okay. Well, this gives us a pretty good hint as to how you might graph this function. You know what the axis of symmetry is. And if you're lucky, you have x-intercepts, okay? In any case, you have the y-intercept. Well, let's apply it. Okay. It's squared, not hidden. I want to graph this thing. Oh, we start with the graph. Can you find the y-intercept? Okay, so you plug in 0 for x, you get 0 here. You plug 0 for x, you get 0 here, and you're left with the negative 12. So now we can put the point 0, negative 12 on the graph. Now, as soon as we put the point here, then we've dictated what the scale for y is. That's perfectly okay. Now, what about the x-intercepts? Well, those occur from y equals 0. You really want to make this second nature. Almost for any function you get, you want to find the x and the y-intercepts. So y-intercept when x equals 0, x-intercept when y equals 0. So 0 equals 2x squared minus 7x minus 12. You just have to solve that equation. Find the x-intercepts and just set your functions equal to 0 and solve the equation. Now, sometimes you can't solve the equation. Sometimes the equation has no solution. It has no solution. That tells you don't have x-intercepts. I mean, the graph is either above the x-axis or below the x-axis, but it doesn't cross. Okay, well, let's go on up here. So we have the equation 2x squared minus 7x minus 12 equals 0. I'm not going to have you solve that because you know how. Just going to write down the solution. X equals the negative of negative 7 plus or minus the square root of negative 7 squared minus 4 times 2 times negative 12 divided by 2 times 2. You know how to use the formula, so I'm just going to mess it up for you rather than you do it right. Okay, so we have this. Okay. 4 times 2 is 8 times 12 is 96. You have 2 negatives, so it's 96. And this is 49. So we have 135. Under the radical sign, that's 4. That's approximately equal to 7 plus or minus. Okay, the square root of 144 is 12 squared. 121 is 11. This is somewhat closer to 12 than 11. So I'm going to estimate that this is 11.7. Might be 0.6. I'm not going to think that hard on it. Okay. So we get this. So this gives us two solutions. We're going to get 18.7 divided by 4, which is 4.7 approximately. Or negative 4.7 divided by 4. That's about 1.2. Those are approximate, but we're going to draw the graph, and we don't need much more than 2 significant figures. The other graph is going to allow us to do that. Okay, so 4.7 or negative 1.2. So I'm going to put .70 here. And if that's 4, then 1's about this big, so 1.2 maybe be about here. So we have negative 1.2. So now I've got 3 points on the graph, and that looks a whole lot like the graph that we did before. We estimate the axis of symmetry halfway between here, so it's going to be about here. And then we sketch our curve, which is going to mess up everything that I wrote down here, but I'm going to do it anyway. Okay, so we're going to come down here. We're going to continue coming around here and come back up here. Okay. Now, what's the equation of your axis of symmetry? Okay. Axis of symmetry is x equals what? There are two things we can do. We can average these two numbers. Okay. X equals and that comes up 1.75. Okay. So now we know what the axis of symmetry is. That's one way to get the axis of symmetry. The other way is x is negative b over 2a. Right there's negative b and there's 2a. And locally, that agrees completely with what we get when we average these. Okay. Now the square root of 135 is not an exact, it's an irrational number. The decimals go on forever, and that would be the case here and here. I just lucked out and got the things that rounded out that would give me the 1.75. Okay. This is the more accurate way to get it, but if you do this to six significant figures and this to six significant figures and average them, you're going to be pretty darn accurate. Okay, you're going to agree very well to six significant figures with what you get if you just divide this by this, but divide this by this is easier. Okay. Now that's a whole lot. We're really pretty much getting the entire picture of how you graph a quadratic function. Okay. Now there is one little catch. Let's say we want to graph x squared plus 2x plus 10 and follow this method. Okay, well, the quadratic formula now I've done the substitution in my head. Okay, the 4AC is just 4 times 1 times 10, which is negative 40. Negative 4AC will give you negative 40. 2 squared will give you 2. And we kind of luck out here because we get negative 1 plus or minus 3i, I being the square root of negative 1, an imaginary number. And the whole point is that the square root of negative 36 is not a real number. And this is a big deal. Is not a real number means you don't have any real number values. You don't have x-intercepts. So what can you do with the graph? Well, it gets a little bit tricky. Okay, your y-intercept is 0, 10. And your axis of symmetry is x equals negative 1. Big deal. There are no x-intercepts because the square root of negative 36 doesn't give you a real number. So the graph can't go through the x-axis. Okay. So the graph goes through the y-axis here. It hits the axis of symmetry somewhere. But where? Well, let's show it on board space. Unfortunately, I can't always plan what I'm going to write because it depends on what you show me that you understand and adapt the process. Okay. So we got y equals x squared plus 2x plus 10. The vertex on the axis of symmetry. That's something you should be very familiar with. You've been dealing with the vertices of quadratic functions for a month now, okay? And you know that they're on the axis of symmetry. If you're constructing a 4x4 rectangle and stretch the rectangle, vertex is still on the axis of symmetry, right? The axis through the red dot in that case, for those who are in my section. Anyhow, vertex is on the axis of symmetry. So what's the y coordinate of the vertex? How are you going to find the y coordinate of the vertex? Okay, so you want to process this. The y coordinate of the vertex is what? Vertex is on the axis of symmetry, right? Vertex is on the axis of symmetry, and the axis of symmetry is x equals -1. Okay. Now that we know the x coordinate of the vertex is -1, how do we find the y coordinate of the vertex? I'll let you figure that out. You probably do it in your head, but okay. Y coordinate is 9. We just plug in -1 and we get the y coordinate of the vertex. So we come over here in our graph. Here's the point 0, 10. So 9 would be about here. So the line where y is 9 is like this. So the vertex would be here. Vertex is point -1, 9. And now we just draw a parabola through these points. And we've nailed it. Now, if you master everything we've talked about today, you pretty much got the pre-calculus part nailed, okay? Master as much of it as you can. Think about this. This is the big picture. And of course, you're going to use this picture in the homework over the weekend. And hopefully it'll pull it all together for you, or come close enough to pulling it together that when we do it again in pre-calculus a week later, you'll be able to do it very easily with very little anxiety or trouble, okay? At some point, the screen blurs, but there it is. Again, just to summarize, to graph this, by finding the zeros, we find that there are no x-intercepts because we get square root of a negative here. We don't get any x-intercepts. And that's going to turn out then that the graph is above the x-axis. We notice that the axis of symmetry is at x equals -1. We can see it right here, actually. So we plug in the coordinate of the axis of symmetry into the equation of the function, and we get the y coordinate of the vertex. We plot it. We already know the y-intercept. So there's our problem.